Hello guys, welcome to the channel once more. Today I'm gonna bring you something that is gonna be a little bit different than from what I normally do. Reviews, PC stuff. Today I'm gonna do a video for a contest that Brady from Practical Engineering, amazing YouTube channel if you're into engineering, infrastructure, that kind of stuff. He's running a contest where he's giving away one of his new books. One copy of his new book that is just coming out. It looks amazing, and the contest is called Engineering in Plain Sight. And basically what it means is that you gotta go and put out a media piece or video or a Twitter thread or something about a piece of infrastructure that you just look at every day, but people look at every day, but nobody stops and realizes how complex it is or what it actually does. So for this, I'm gonna explain a little bit today how the flood control works in my home city, which is Houston. You may have heard that several years ago, there was this hurricane called Harvey, which even though it didn't have fast winds, it kind of like flooded the entire city. The drainage system was just overrun. And I just want to talk about a little bit how it works, what could have been done better, and what are the steps forward to mitigate or try to avoid something like this from happening again. So I just want to start by saying basically stating the problem. The main reason for the problem of flooding in Houston is the geography of the city. So Houston is incredibly flat. We go from the elevation of one of the biggest western suburb, which is Katy, at 120 feet above sea level to basically 0 feet above sea level at the San Jacinto Bay. And we're talking about a 46-mile length, which translates to a slope of 0.06%. That's basically flat. There's no slope. On top of this, Houston has several bayous crossing the city. You got the Buffalo Bayou, Brace Bayou, Cypress Creek, Greens Bayou, Hunting Bayou, and many more. They kind of like aid in the flood control system, and they don't technically come close to the downtown, but still they all pour their waters into Lake Houston and the San Jacinto Bay. On top of that, Houston, as many other cities in the United States, it's a city that suffers from big urban sprawling as well as a huge boom in land and urban development. This brings, more areas of land being effectively waterproofed with concrete for parking lots, roads, sidewalks, etc. So the water can't really permeate through the soil, and it has to be managed and taken somewhere every time it rains. Houston counts with many different infrastructure and requirements for the flood control. Some of these are, for example, the reservoirs. Currently, Houston has two main reservoirs in what used to be the westernmost part of the city. These are the Addicks and the Barker reservoirs. These were built by the Army Corps of Engineers between 1942 and 1948, and at that time they cost around $40 million. These two reservoirs are the main line of defense against flooding for the city, since the slope of the city goes from the west all the way to the east, and these two reservoirs contain the water of most of the bayous and all the runoff water all the way to the west from their location. And these reservoirs are designed to withstand a 100-year event without the need of opening the floodgate. But that was based on the calculations from 1940s. So at this point, the amount of urban development and waterproofed areas west of the reservoirs have increased dramatically, so these calculations are no longer valid. The idea for these reservoirs was to contain all the water from upstream and then release it under control to the Buffalo Bayou. Here we have the first problem. Both reservoirs pour their waters into the Buffalo Bayou. So, and this is gonna come back whenever we study what happened during Harvey. We have a crazy amount of water going into just one bay. The gates of these reservoirs allow the water to be released, and they are under a controlled manner, and they are meant to be open and closed during discretion, depending on the amount of water that's coming into the reservoirs, as well as the water that needs to be released from the reservoirs. Both reservoirs also have emergency spillways, but the problem is nowadays there are businesses, residences, roads, things were built around the emergency spillways. So if water were ever to have to be drained using these spillways, then we will have flooding. Then we have the bayous. Now the bayous were mostly natural, they already existed, but they have been, adequated to the needs of the city. The Buffalo Bayou being the biggest and the deepest of them all. I mean, when I say the deepest, I mean that in some parts there's even navigation on the Buffalo Bayou. You can actually rent some tours and you can just go around. There are boats that are actually able to go on the bayou. The Buffalo was conditioned as part of the project for the Addicks and the Barker reservoirs. It was dug deeper, it was channelized, and this happened between 1950s and 1960s, which means that the capacity overall of the bayou was increased, but for standards that were applicable at that time, not today. Another important bayou that we have is the Brace Bayou, which runs roughly parallel to the Buffalo, even pours its water into the Buffalo Bayou at the east of downtown. And the capacity was increased and a big length of the bayou was channelized. But since 1980s, this bayou has not been able to contain anything more than a 10-year event. Here's the problem. So during Harvey, this bayou actually overflooded. And I've been close to this bayou multiple times and I've seen it being 4 or 5 feet from its top just during regular heavy rain events. So in case of an emergency, this is not a bayou that you want to be counting on, but still it helps controlling the flooding problems of Houston. Now, there's another requirement, not another requirement, but something else that the city does to help mitigate its flooding problem, and it's the detention and drainage regulations that the city and Harris County have put into place for all new constructions. So the idea is that all the new land developments that are over 50 acres, they need to be able to collect and hold their runoff so it can be released into the city's drainage system at a rate that will not increase flooding downstreams. So what it means is that the detention requirements will vary greatly from one project to another, and engineers have to calculate what were the pre-development levels of runoff and then have to calculate the post-development runoffs, and then the difference they need to be able to mitigate and contain that amount of water. So if you drive around Houston and the suburbs, you will see these big detention ponds around all the new land and urban developments. You'll see these empty spaces of land, sometimes even 10 feet deep, and you will think, this is wasted space. Well, it's not. The developer has to account for all the water that land development is going to produce whenever it rains, and he has to contain it and release it to the drainage system at a certain rate that it won't allow flooding downstream. Now, the problem that this carries is that if a developer, for example, is going to develop an 80-acre piece of land, they have to take into consideration that not every single square feet of the land is going to be allocated for roads, sidewalks, and lots, sellable lots. Some of these will have to be used for these detention ponds, and it kind of messes up a little bit with the price in the end. For sites under 50 acres, the city of Houston provides a simple formula to determine the volume of required detention. The formula is based basically into impervious surface, distributed area, and length of storm event. For single family lots, say 15,000 square feet or less, no detention is required in most cases. It will have to be analyzed in a case by case situation, because sometimes the single family development may increase the total volume of water being discharged downstream. Another thing that some developments may do, for example, and I've seen it personally, if you're talking about buildings close to downtown where the square foot of space is so expensive that you cannot just go and account for it with a detention basin. What we tend to do is there's technology called underground detention, where you basically you dig deep under the building and you create this chambers, like a cistern. You create like a cistern underground where you're going to collect all that water, and then using pumps you're going to pump it out into the drainage system. Expensive, but sometimes due to the price of the square footage, once again, doing an above ground detention is not viable. Things like, for example, and here's another problem: the drainage systems of the city sometimes are not the best. There are places around the city where there are no drainage pipes, drainage inlets, and still they are using like ditches to collect the water and then dump it somewhere else. That's not feasible. It's slow draining and it doesn't help the problem. It just, it's like a band-aid. It doesn't solve it, but it is what it is. I mean, we still have too much to develop. During Harvey, the waters reached record heights. On the Addicks Reservoir, the water reached almost 110 feet above sea level, triggering flood around the emergency spillway, which has an elevation of 108 feet above sea level. Around 10,000 homes are inside of the reservoir nowadays and suffered some sort of flooding, but the pooling didn't even reach its maximum pooling levels. I mean, it could have gone even higher. Due to this increased elevation, the waters, the Army Corps of Engineers had to open the gates even more than what it was planned, and more than 4,000 homes downstream on the Buffalo Bayou were flooded. If we look closely at the floodplains of, for example, the Addicks Reservoir, we can see that the flooding went beyond the 500-year event. So Harvey was actually able to put more rain into the Houston area than the 500-year rain event, or what they thought it would be possible, which is pretty much incredible. There are certain plans nowadays put into place regarding what's going to be done after Harvey. One of these is the Cypress Creek Reservoir. So this is going to be a third reservoir that is going to be carried out by the Army Corps of Engineers again, and it has a budget of $500 million. The idea is basically to build a new reservoir upstream from the Addicks and Barker reservoirs in the Cypress Creek watershed, basically northwest of Harris County, to help contain those waters before they reach the Addicks Reservoir. There's also a complete 6 Bayou projects, which basically it's going to take $1.36 billion. Once again, it's going to be carried out by the Army Corps of Engineers, and the idea is to recondition the Brace Bayou, Hunting Bayou, White Oak Bayou, Clear Creek and their tributaries, the Greens Bayou and the Holtz Bayou, basically to increase their capacities and to be able to deal with the water better. Harris County Flood District is thinking about doing large-scale detention bases carried out around the city with a budget of $500 million, and basically it's just trying to contain more water to be able to distribute it easier and slower, so we don't have flooding downstream on the bayous. Then the biggest project of them all, which is actually not going to help in the case of a heavy rain like Harvey, but it's going to help in the case of a high category hurricane coming from the Gulf, is going to be the Ike Dike Coastal Spine Storage Surge Protection System. It's a long name. It's going to be carried by the Army Corps of Engineers, and according to this side, it's going to have a cost of $12 billion. The idea is basically to construct a seawall along the Galveston Island and Bolivar Peninsula. And the idea came from the devastation that Hurricane Ike did on the Galveston area. And it's gonna also come with a series of floodgates installed between the Galveston Island and the Bolivar Peninsula to control any surge that may come due to a hurricane. The problem with this project is its extent. So we are talking about building a dune wall in the Galveston Island and Bolivar Peninsula of around 43 miles long and 14 feet tall. The 22 feet high surge gates that are going to be installed between Galveston and Bolivar Peninsula are going to allow for sea traffic to come in, but hurricane surges to be stopped. Now, the problem with this is that, like, if you remember, I said that this cost, according to Harris County Flood District, is going to cost around $12 billion. But newer studies and newer feasibility studies put the cost at $29 billion. And some experts think it's going to take between 12 and 20 years to be completed, which is incredible. At this point, we're seeing, people are trying, well, people not, the government is trying to get some private investors to put money into this project, especially in the Galveston area and southeastern area. But it's gonna be a while until the budget is procured. Now, what if I told you that Harvey could have been prevented? Most probably, which is pretty sad actually. So it turns out that in 1996, May 1996, the Harris County Flood Control District Planning Department published a report where they incredibly foresaw all the destruction that would happen 21 years later to an incredible precision and proposed a rather simple but cost-effective solution that was never implemented. So at that time, it was determined, 1996, the inability to drain the Addicks and Barker reservoirs in an efficient manner. They already knew it. And at the time of the report, there were about 6,000 structures and 8,000 acres within the reservoir fringe areas, which means effectively inside the reservoir, and that could be subject to flooding. It was estimated at that time that the number of structures could increase to $20,000. Honestly, that's not far from what we are seeing today. It was also determined that it was not needed for a large storm to come in and just flood the reservoirs and the city. It was just enough for enough rain events to be one after the other for this maximum pulling capacity of the reservoirs and the drainage system as a whole to be achieved. So we didn't need a Harvey. We just needed enough really bad rains to come one after the other for these systems to collapse. And the reason is that there was not enough time to empty the reservoirs before the next rain system come, so that the reservoirs would have enough space. At that time, several solutions were proposed. So buying all the reservoir fringe areas was another option. Excavating more storage inside the reservoirs was another option. I mean, there were many. And at the end, they said, we can do nothing and set the risk of flooding. And that's what happened. Now, you might say, what was the solution that they were going to come with? They were going to propose. Well, it was pretty simple. At that time, around 2000, in 1996, there was already the project to expand the Katy Freeway corridor under the Interstate 10. This report they saw that it was the best opportunity possible to excavate under what's going to be the new freeway and installed a new system of drainage pipes to effectively increase the discharge capacity of the reservoirs. It would have been the perfect opportunity. I mean, TxDOT was already going to demolish the whole highway, and you didn't have to spend much money. You would just wait for them to demolish the highway, and as soon as the ground was cleared, you would dig and you would be able to put those pipes down. At that time, this project would have cost $400 million, which would have been around $800 million of today's money. Harvey had a devastation that cost around $125 billion. So it would have been almost nothing. Now, these conduits would have stand all the way from the reservoirs to the White Oak Bayou, or maybe even to the ship channel. They weren't clear about it. But the thing is that they had two options. Either 8 12 by 12 feet boxes or 6 14 by 14 feet concrete boxes. They would have provided the required 8,000 cubic feet per second drainage capacity that it was needed to be able to safely drain the reservoir. The report clearly stated that they needed an actual feasibility study to be able to achieve this project. And it was published, but it wasn't followed. Imagine where we would be nowadays here in Houston if that project would have been done. It was the perfect time, it was the perfect chance. They could have done it, and most probably Harvey would have been avoided. Unfortunately, it wasn't. Now we just have to learn from our mistakes. And at this point, we hope that the new projects that are being proposed will be carried out and we won't see another thing like Harvey happening. I hope this was useful. I'm gonna list all my references down in the description. I see that it was a little bit long, but I hope that you got something useful from this. Like I said, this is merely, a little introduction to how the flood control system of Houston works. It's more dense than this, but I hope that you guys get a nice picture of the situation, what could have been done, what it's going to be done, hopefully. And thank you so much for watching. Really appreciate it. If you have any comments, suggestions, questions, just please leave them below, and I'll see you on the next one. Bye.